Welcome to the talk Evolutionary Software Architecture. So I don't need to introduce myself. Hi, I'm Markus, but yeah, I just want to say that I really like working on software systems. So software quality, why is it so complicated? I guess everyone knows how important software quality is, so why just not build it just in our software systems? Well, we need to talk about the stuff in a very detail. And first of all, we need to get some basics out there. So for example, what I want to talk about is just how a software system should behave, how it should be enhanced, how it could be deployed, how easy it is to bring some new code in. And the talk is not about the what, so what should a software system do in detail. And yeah, I want to speak about what actually good software quality mean and how can we, in the end, find the right amount of quality at a specific time of a software system's lifespan. Because it's pretty easy what software quality means here for our software systems. You have the right amount of quality if the thing that needs to be there is there at the right time. So this sounds pretty simple. And we are struggling with this to find the right amount, and we are struggling with this to find the right amount of quality at the right time a little bit. And there might be some challenges why, and I want to tell you also about first solutions for this. So first of all, the problem is there are so many qualities out there, so many quality attributes. So there's a list of quality attributes from Wikipedia. And the first thing is, are we actually talking about the same things when we're speaking about, hey, let us build in resilience, let us build in scalability or flexibility. And there is something that can help us. We just need to find kind of a common language to speak about the same at first, to get them clarified what kind of quality we actually need in our software system. So this is not a problem anymore, I guess, because when you use a quality model, for example, like the ISO 20010, and then go to our stakeholders and ask them for the kind of goals they have regarding this kind of terminology. But it's hard to find the right amount of quality because we have different stakeholders. So we need to know who's working with these software systems in the end. We need to ask them. And maybe there are some different views on which kind of quality is actually needed in a software system. So we need to challenge assumptions. We need to go together and to speak what we need from a specific point of view, from a specific stakeholder view, to get a set of quality goals where everyone is happy. And another challenge is that quality or the need for quality is ever changing. So you cannot just build in quality once for one specific point of time, but we need to adapt because software is evolving. So we need to design the quality goals for constant evolution to come up with new ideas that customers have for our software systems, for the new needs that users might have in the near future. So it's not so easy as it seems to be, but we can kind of get a kind of thinking model that could help us a little bit to find the right amount of quality for the right time for the evolution of a software system. So I want to introduce you to the first part, what's really helping me, which is kind of an evolutionary thinking approach, where we can anticipate which kind of qualities we won't miss building in our software system. So I think it's worthwhile to talk about this, because we come from a perspective as software developers where we are thinking in 0 and 1s. But when we're talking about quality, we're also talking about architecture. And architecture is not just 0 or 1, true or false, but it's somehow in between. And for me, what can make this a little bit more contextual or a little bit better to understand what's in between 0 and 1 is an idea from some Wardley, which is called evolution, and actually embedded in a bigger kind of methodology framework, which is called Wardley maps. So what does evolution mean in the end? We have a software system And if it's very successful, and we can, as developers, also implement all the wished features or the feature requests and so on, and we can deliver the software. And there's also some users or customers out there that need what we are providing. A software system will evolve over time. We don't know when exactly, but success is kind of a driver for this. And we will also go through different stages of this evolution process. So for example, in the Genesis phase, where we have absolutely no clue what we are trying to do, and we are absolutely not sure if people that don't know what we want to do want to buy this. This is really typical for software systems in this phase. But if we are having a software system already deployed in production, and maybe we are providing it as a cloud service out there, it could be that our software system is well known, that we have a mass market out there, we have great ideas and great developer skills to produce or to fulfill the actual needs of a wide variety of customers and users. So we will use this idea to take a little bit, to take a closer look how we could use that to prioritize quality goals. But I don't want to say, or before that, I want to say my goal is not to say when you don't want to build in quality in software systems. My goal is to tell you how that you don't want to miss at very specific stages of the evolution for your software system, thinking about additional quality goals, so that we understand each other. All right, for this, I want to take a closer look what the evolution axis actually is. So it's made up of two components in the end, which is on the one side here, demand competition, which is nicely defined by Simon Wardley again as the consumer desire for anything which is useful or makes a difference or creates an advantage in the driver for ubiquity. So that means that we can see here the demand of the customers, of the users. They want to use our software system. The other axis, the evolution axis, is supply competition, which is defined as the desire of providers to supply an activity to consumers is the driver for feature completeness and improvement of an activity. What does that actually mean? So this is the certainty where we as development teams can provide quality that is suitable for our users in the end. Simon Wardley took a look at this and also found out that there is some typical S-curve here involved, where we can see how those two axes work with each other, or these two components. For example, at the beginning, we need to provide a proof that we can do something, that we can produce a software system. And later on, users see, hey, there's a working great idea out there, implemented in code, delivered by a great software system out there. And then they get on board, and we get successful as the people and the developers who are in charge of those kind of systems. What we can also see are these different stages again, because actually I just divided this evolution axis in two other axes, and we can still map those different stages on this graph as well. So this is just the thing that we need. We don't know anything new than before. We have looked at the evolution axis with these different stages. But now we can take a look at what this actually could mean for us when we want to get a deeper look into which kind of qualities are at the latest required to think about for our software system. So I brought with me something I not coded, but kind of implemented in PowerPoint, which you can see here. So we have here different quality characteristics, and the goal is to map those to the different stages of evolution of a software system in the end. You can also see the amount of supply competition, so how good can we deliver something, and demand competition, so how, in the end, is it needed by customers or users. And we also see the S-curve again, which I will slowly build up to give you an idea which kind of quality characteristics we need to talk about and to think about in the early stages, and which one we could actually address in the later evolution stages of a software system. So this is the beginning. As I already told you before, we are a startup, we have an idea, we want to find a great product fit, we want to get customers and getting millionaires. And what you need to do is to bring some initial investments on our side to prove that we can build a software that somebody out there will need. So this is very typical for the Genesis phase that we have here. And hopefully we will get out this Genesis phase because the first customers get attracted by us. So they see, hey, there's a need that I have that these development teams can actually fulfill. So the rise in the demand is a little bit increasing here. And there we could think about which kind of quality characteristics are now very important to think about to enable a continuous evolution of our software system. So there's a simple mapping, and I will go the first step to show you and then ask you later what you mean. I think this phase is especially important to get your head around regarding functional suitability. So why? Because at this phase, you want to be very clearly what your software system should do. You want to have a narrow scope. You want to deliver the really valuable things. You want to prove that you can work on these valuable things with your software system. And the next thing is you want also prove that you cannot just do it once. So you click on a button and then the calculation is done in your UI. But you want to prove that you can repeat this kind of calculation very often. So you might think about how can I deliver then a software system that doesn't break the second time the user uses it. So this is how the mapping works and how the S-curve is evolving. Because we are now with our software system very successful, and there's a high increase of the demand side because users are so happy with our software system. And the question is now, what do we at the latest need to think about now? So we are typical in the custom build phase, which means we have proven once that we can build a software system. Maybe you have a small customer base already. And the question to you is, what do you think might get more important now to think about? Is it maintainability? Is it usability, security, or something like? What do you think? Why usability? Because we want to use it. Exactly, that's one thing. Because we have now a very diverse audience, maybe for our software system. Maybe we have people that don't know how to work with software systems, very naturally. Maybe we have also more aspects regarding aesthetics or something like. And this could be a point and an argument to care about this one, exactly. But also what comes with usability is performance efficiency. You see the curve is rising, and it's even rising more. And that means we are onboarding more and more people on our software system, be it on their own site with on-premises installations or maybe in-house with our installations and deployments. But nonetheless, we get more and more attraction of users, so we need to care about things like scalability, maybe elasticity, or in general resource consumption, because the tiny little Raspberry Pi for our first prototype doesn't scale that well with this high amount of user requests anymore. Could be. So this is how it goes on. So there's now the product phase, which is kind of, you build a system and then you can get it off the shelf by a vendor or something like. There are also some key points what you think about regarding quality, which is, for example, security and maintainability. So why security? So demand has risen again. And that means we get all these customers from bigger companies maybe. And they are asking tricky questions. For example, where is your nice German word, Datensparsamkeit-concept? That means, how do you care about just storing the data that is actually really needed for use cases? And we need to have an answer for this, which falls into the category of security. And why maintainability? Because you can see that the curve here is turning to the right. And you can also see that there are plenty of demands that we need to fulfill as a software development organization. And that means onboarding, for example, or scaling up our development capacity. And there in this phase, it's not the worst idea to think about things like, how can we structure our software system? How can we document the main concepts that our software system consists of? How can we find a kind of modules that our software system is made of? So these are all the kind of things that we need then to think about when we are thinking about maintainability in a general sense. And there are two left. So demand competition is rising, supply competition as well. So we are entering the phase of commodity, of things like software as a service kind of stuff. And then we have two others, so compatibility. So typically, in this area, you want to, for example, write a public API for your software system so that others can build upon your software system. And you want to have freedom for deploying your software system. This is what portability means. So we can then deploy on different cloud providers. Maybe your customers can choose their own hardware development runtime or deployment runtime, whatever they have. And this is why portability comes, again, very attractive to think about at the latest. Or at last in the end. So let me just rearrange this a little bit to the initial view. So let's put those two axes together. We see the evolution axis again. And we can then think about, so nice, but what now? So what's the point of all of this? Well, I think you can, as an architect, use this first part of the model to communicate that there's always something that needs to be done in the near future. So if you have a software system and your software system is pretty successful, it will evolve. If we can deliver and satisfy the customers, and if there are customers and users. And that means that you need to care about those topics if you want or if you don't want to do this. And you can also see if there might be some wrong priorities taken by you. If you take on compatibility, so you are designing a nice API for your external developers or whatever you have. And then you see nobody can get into this kind of idea and how to structure the API because your code base is a mess. So maybe it's then worth to shift priorities to first care about better naming, a better structure of a software system, information hiding, yada yada, all the things, before you start exposing your kind of internals to the outside world via a nice API. The other thing is, if you are like me and you have a lot of fun with software modernization projects, you can also raise awareness that it's not so easy to rewrite a legacy system that runs already in production. Yeah, you have some colleagues maybe, they say, hey, take a look at what we already have achieved. See all the nice buttons that we have and so on. And as a developer of the legacy system, you know, nice. We had the same feelings like 5 years ago. But let's look what is lying before you. So you have to deal with the same kind of complexities that we already had in our legacy system. And if you are coming to the point where we are right now, let's see if your code is still great maintainable, if your developers still have fun playing around with new frameworks, or if the essential complexity is here in the end so high that we end up with also a legacy system, but with a new legacy system. So this is something that you can also see, and where you can speak up, for example, if you are the main maintainer of the legacy system, that people maybe from the new system underestimate the efforts that are needed for this kind of rewrite. But you can also see, and this is some kind of a story that it's my own startup or attempt to run a startup. This is a situation that we had because with our startup, we wanted to be the first startup that would be, from the beginning, successful applying clean code. So our focus was to get into maintainability at first, with clean code, with clean architecture, and so on. What we also did was we developed cloud native because we had no money for our own servers. We also had plenty of ways to store data. So an in-memory database, a relational database management system, NoSQL, and so on, because we could. And we completely neglected the user's need. So we had fun playing around with all the stuff, but nobody needed our system or our app in the end. So the startup failed after that, where our brainstorming about how we can enable third-party widgets to enable external developers also to enhance our software system. And we saw no way that this will work in the near future. And now I can say, yeah, because we missed thinking about very, very important other qualities that, were not addressed in our software system. All right, so that's the first part. So, nice story, I guess. But I want to tell you another part. I think it's very important for prioritizing quality goals. And this is that you don't have to work on even more and more things in your software system, but it's getting harder and harder because you are so deep down into the very technical specifics that it's hard for product managers to see what you are talking about. And there, value chains from Wardley mapping can help us as well. So first of all, what is a value chain? So I brought an example with me, a chain of needs. So for example, I have a gamer who wants a better gaming experience, a new graphic card, and so on and so on. And a value chain tells you what is needed and needed and needed to fulfill a need that is something that the gamer wants, for example. So that builds a chain. So a backend needs a runtime needs virtual machines, and so on and so on. What's also interesting with value chains is that there are some parts that are very visible to users of a software system or whatever they have. And some parts are invisible. Yeah, okay. Sometimes you get a look behind the curtains. For example, this is a request of a flight search engine here that we have in Germany. And it didn't work, so it said somehow whatever, access denied. So you could look behind the curtains. But actually, you don't have to care about this because you just want to do your stuff, whatever it is, as a user of a software system. So what can we do with this value chain? We can also see what the stakeholders' perspective on quality is. So this is something very typical. So for example, user is interested in usability. Yeah. The boss wants to see that all the contracts are fulfilled, so it should work as specified. And developers who has guessed maintainability is very important to them. So this is not a thing I made completely up or try to do it in a rational way like the other part. But this is some kind of a empirical data set that I have here because I asked in several training trainings for software architecture, the attendees, hey, slip into a role, into a user, a boss, or a developer, and from this perspective, tell us what's important to you. And there we got those listings. So what can we do with this? We can take a look at various ways. So for example, we could intersect or the people that are more business people. So the user or the boss and the developer, so business and technology. And what you can see in those listings are these typical differences. For example, that both users or the business side seems or wants usability as the first priority, and developers don't really care about, but they care very, very about maintainability, which is absolutely nothing that the users or the boss can see or have in mind when they are talking about what quality means to them. So this is one kind of aspect that you can see here using kind of a value chain. And then we can also talk about what happens if we combine those three views into one, which is mathematically or statistically maybe not allowed there, but I do it. So what we can see here, you have so many qualities that are visible to business and tech people. And there you go. You have many qualities that are only visible to the tech people, but not the business side. And there we have it. So the good old external software qualities and internal qualities, things that can be seen from the outside and things that can be seen if they are not there, especially by developers. And what we also see that this view might be somehow familiar because you already saw that. Because this from the first part, the listing regarding the evolution, functional suitability, reliability, usability, and so on. But now also with a view of external and internal qualities, where we can see what business and tech see, and what's only visible for tech. And that could be also pretty helpful, especially if you have a software system that wants to make the transition between custom build and product kind of evolution phases. Because there you are in a critical phase because you're switching from things that everyone sees to things that just the developers see. And what does that mean? Yeah, you're somehow facing a new challenge. Because for the upper qualities, you could always say, hey, you see that this is not working in this part of a software system, or you see, hey, this is so slow. Your daily report, needs to generate kind of 3 months to generate. So you can immediately see that this is not fine. But if you are moving, or if your software system evolves, you're getting deep down into these kind of areas where your stories from up there don't work anymore because product people or business people don't understand you anymore. So if you say, hey, we are not compliant with this API standard XYZ or something like this, they just look at you and think, yeah, nice. So move on with the next feature, please. And what this also means is you as a software architect or developer need to come up with other stories to get them motivated. For example, regarding portability. So if you want to introduce Kubernetes or some other container runtime, whatever you have, you just can say, hey, we need a few months to deploy everything in a Kubernetes cluster. You need to make it a little bit indirect. You have to say, hey, are you interested that we don't go down at the Black Friday events? So I have a solution for you where we can deploy multiple instances of our software system on the cloud to get those kind of hard times regarding the Black Friday moments out of the way. So this could be an example where this kind of model could help you to get the right words for the qualities that you think are now especially important. So let me just summarize what we saw. without evolutionary software quality, or at least some aspects of this, I think we'd always get situations like this. So you have a software system, and some team members see the software system more on the Genesis custom build evolution phase. And they totally are against things like documenting your stuff. They shout out here, hey, we don't need to write documentation, we are so fast, documentation is always outdated. Could be, but maybe you have other team members on the right side who see your software system already in the product phase. And they shout out here, we need comprehensive documentation, otherwise no one will use our stuff. So they have already qualities in mind that are getting now really important to get the software system towards the right. And you have other people that see here, that they think they are not ready to think about those qualities. So with evolutionary software quality, my hope is that we can also getting more and more better understood by several team members, product managers, business people, what kind of investments are now needed to be taken, maybe also deep down under the hood of our software system. And that maybe people that think, we are way more evolved than we actually are, also get down a little bit and just work on the things that are now really important. So that's my hope for this. So maybe someone says, maybe then just a little bit documentation, because we are not so scaling up with our development teams. We don't need a high amount of maintainability, for example. And others are perfectly fine with this because they understand that they don't need to write the next 100-pager of architecture documentation or something like, because they see, just a small one, a little bit here and there, and they are perfectly fine with this, and we can understand each other a little bit better. So that is my hope in the end. Of course, the final obvious warning, so all models are wrong, but some are useful. And it's also not my goal to come up with the very generic golden whatever model out there, but it helps. It helps in discussing priorities. It helps in getting developers on board, what needs to be done now, what can be postponed a little bit. So that's why I like this kind of model, because it helps me. Thank you a lot, and I hope it might also help you, and I'm very interested in what you think about this. Thank you. Thank you.
Thank you. Brilliant. We've got 5 minutes and 7 questions. So let's see how many we go through. The first one, how comes that security is so invisible on the developer's value chain?
So because it's an ugly kind of activity to develop, so it's at least the things that we first think about. But the nice thing is, what I'm observing, that the priorities in this kind of trainings, the priorities for security are increasing at the last few months or years. And there might be hope as well that security gets up higher in this kind of value chain. Because, thanks to hacker attacks and something like, people from the business side also get more and more aware of this. So that could be an evolution of the model itself.
Thank you. When maintainability comes so late in the value chain, can most of its advantages still take effect?
So last part was, please?
When the maintainability comes so late, can most of its advantages still take effect?
Oh, yeah. So I don't want to say that you need to postpone this kind of maintainability goals. So I'm a big fan of clean code, obviously, but it could turn around. But it's the normal way in the end. So people do postpone maintainability at the last point possible, and then have a big spaghetti monster or big ball of mud and don't know why, because it just ignored it completely. So yeah, it would be great to have maintainability in your project higher prioritized, because you know where it would end. But you can also see, if you start too early, if you think about a modularization of your software system where you don't know what you do, maybe it's also hindering you then later on to switch your approach or the ideas of your software system. So be careful. Yeah.
Would you prioritize the quality requirements the same for B2B environments where the number of the users is limited?
So it's kind of a difference. Customers regarding users and so on, it depends, of course, a little bit. But in general, I think so. But B2B customers are not so, let's put it this way, used to great quality software. So maybe, we can shift priorities there. So that's what I want to say. So it depends a little bit of the context, as so often in software architecture.
Sounds like a consultant to me. So next question. Do you have any hands-on recommendations on how to analyze quality requirements and on how to treat them similar to other backlog items?
Yeah, I'm a big fan to make quality requirements a first citizen, so to speak. So just put them under your backlog together with feature requests. And if product owners don't want to let you work on those, make it transparent that there might be risk involved now, that in the near future your software system cannot be deliver your features fast as the current speed. And personally, I'm very fine with this kind of approach, because I'm not the one who determines, as a non-engineering team member, I'm not the one who decides how the product should be. That's not my role in the end. But as an architect, for me, it's very important to be transparent what we are neglecting now, so where the risks occur and so on. So that's my approach there. So I'm not so, I don't have so high expectations or demands for a software system that runs very well, as you can see.
So we have only time for one last question. So I'm the dictator, so I choose it. How do you ensure awareness and sponsorship on internal quality requirements? Yeah, so I would just say be transparent where this leads to. So that's the answer that I gave before, I guess. Because as sad as it sounds, it's not my product. It's a product that I'm working on. I try to do the best, and if others say the product fit is perfectly fine for B2B customers, that it's crappy to use or something like this, what should I do? So I can just address it that, we might have some different opinions on this, which could be fine, because in the end, it pays the bills, and it's good enough for the B2B customers, for example. Yeah, let's thank Markus. It pays the bills. Well, thank you.